Welcome to week 5's class. In this video, we will talk about ideal gas equation, which you may have learned in chemistry class. Ideal gas equation has many different formats. We're going to start from the first one, which is P equal to rho RT. P stands for pressure, and the unit for pressure is Pascal. It is SI unit. Remember before, in the first week, we said you can have two options when measuring pressure. One of them is gauge pressure, and the second one is absolute pressure. And which pressure should we use in ideal gas equation? It has to be absolute pressure. You cannot use gauge pressure in this equation. Okay, just to help you remember, what is absolute pressure and what is gauge pressure? If you start from vacuum, if you use vacuum as the reference to measure your pressure, then the solution will be absolute pressure. We call it P with a subscript ABS. This is absolute pressure. However, if you use atmosphere as the reference to measure pressure, and then the pressure you measure is called P gauge. Here is PATM. The relation between P gauge and PABS is like this. PABS must be equal to P gauge plus PATM. And in ideal gas equation, we have to use PABS. Okay, so it's the first unknown in ideal gas equation P. The next one is rho. What is rho? Rho is density. And the SI unit for density is kilogram per cubic meter. And then the second parameter in this equation is R. What is R? R is called gas constant. The unit for gas constant R is kilojoule per kilogram per Kelvin. And be careful here because kilojoule is not SI unit. Gas constant depends on what kind of gas you have. So for example, if you have air, the value of R will be a certain number. However, if you change the gas to oxygen, then the value of R will change too. Okay, then the last parameter in this equation is T. T stands for temperature. The unit for temperature is Kelvin. That's the SI unit for temperature. Okay, and like we said in the beginning in this video, ideal gas equation has many different formats. The first one we introduced here is P equal to rho RT, and it has many alternatives. So what are the alternatives? The first one is let's recall, we start from P equal to rho RT. Okay, we start from this equation, and then first alternative is to move density to the left-hand side. So this equation becomes P over rho equal to RT. And then let's recall 1 over rho is equal to nu. 1 over rho is equal to nu. The inverse of density is specific volume nu. So now we can rewrite this equation into P times nu and equal to RT. So that's the first alternative. Pressure times specific volume equal to RT. Second alternative. Second alternative. Second alternative is to multiply both left-hand side and right-hand side with volume. So it becomes P times volume equal to density times volume times R and T. And then we can keep left-hand side, which is PV, and then right-hand side becomes rho times V, density times volume, that gives you mass. So it becomes MRT. So that's option number 2. PV equal to MRT, where V is volume. Okay, and then option number 3. Option number 3. We start from PV equal to MRT. We start from here, and then what we do is we do a math trick. Mass divided by molecular weight multiplied by molecular weight multiplied by R and then multiplied by temperature. So divided by molecular weight and then multiplied by molecular weight, they cancel each other, so the equal sign is still valid. Okay, why do we do that? First of all, mass over molecular weight is something else. Mass over molecular weight is molar number. We use letter N for molar number. Letter N for molar number. And next one, molecular weight multiplied by gas constant is something different, and that is called R bar. R bar has a name, that is universal gas constant, and then temperature. Okay, so in summary, the third option is P times V equal to N R bar times T. Okay, so first of all, V in this equation means volume. And the SI unit for volume is cubic meter. And then N in this equation stands for molar number. And the R bar in this equation stands for universal gas constant. And R bar is equal to molecular weight multiplied by R, and the molar number N is equal to mass over molecular weight. Okay, R bar is really easy to use. Why? Because R bar is a constant and the value of R bar doesn't change no matter what kind of gas you have. So it's much easier to use than R because the value of R depends on what kind of gas you have. But R bar is always a constant no matter what kind of gas you have. So what is the value of R bar? R bar is equal to 8.314, and the unit for R bar is kilojoule per kilomole per Kelvin. Okay, and one last thing, MW stands for molecular weight.